Hello and welcome everyone. So we have started our discussions on Matplotlib. Okay, in the previous session we have seen some basics of Matplotlib. We saw what are different parts in the figure and we also saw somewhat the architecture of Matplotlib. Now we'll first go maybe a little bit over the important things that we covered in the previous session, so that I just refresh your memory so that everybody is on the same page. Okay, so I'll just go back to the code window and just refresh these things maybe in a couple of minutes, which I find is quite important. The first thing is there is something called as pyplot. Whenever you import something, so let's suppose we'll write import matplotlib .pyplot as plt. So there is something as pyplot. Okay, let me just type that thing. Okay, I'll just import, there's a cell. So if I write import matplotlib.pyplot, if you see this, pyplot as plt. Just let me activate this so that it is, and then I can import numpy and pandas also. Import numpy as np, import pandas as pd. Okay, then I also want my charts to be inline, so it is better to write matplotlib then inline. It's for the Jupyter notebook. So if I run this, it successfully ran. So the first thing I would again love to discuss is pyplot. Okay, if you see this over here, so here I have written this pyplot, matplotlib.pyplot. So we are getting into the folder of matplotlib, and there is a folder pyplot. So I'll say what pyplot is. So pyplot basically provides you the set of functions. So this pyplot, what it does is it will provide set of functions. Okay, so it will provide you set of functions because as I said that this matplotlib is somewhat inspired from MATLAB, because MATLAB had the capability to make visualization, so it was inspired from that. That's why these pyplot, the functions it provides, it will resemble Matplotlib. Okay, so let's suppose we might have seen plot.figure, we saw plt.subplots, we saw plt.label, we saw plt.legends. All of these are functions which are provided by pyplot. And one more thing that's important to remember here is that it has stateful nature. What is the stateful? The pyplot has stateful nature. Okay, again this stateful nature is a generic term. So stateful nature basically means pyplot keeps the track of the current figure. So whatever you did so far, if you did something on it, so previous thing will not be squashed, previous will be still there, so it will basically preserve the state. And whatever when you call a pyplot function, you operate basically on the current figure that you have. If no figure exists, it will create the figure. If figure exists, it will do that on that particular thing. Okay, so that's the meaning of this stateful nature. And then we saw two approaches. We saw that how can we use this. So there are two approaches. The first thing we said is called as object oriented approach. The object oriented approach, and then we saw there is pyplot style. So these were the two things that we saw. I'll just write the code for them maybe in a couple of seconds so that you again remember that these are two things. Rather, document mentions three things that you can use these plots. You can rather create these plots in three ways. So two are the things that we'll do in Jupyter notebook, and one is in the particular environment. So if you do it in the let's suppose OOP style, that means object oriented style. So in object oriented style, what we do is you basically create objects. So let me just create some data over here. So I'll just paste some code. So if you see this, so I'm creating some data by using numpy, then I'm creating some y-axis data, that is applying sin x on this data. And if you now see over here, so I'm calling this plt.subplot. So what it basically gives me, it gives me a figure and an axis. Okay, axis basically a figure contains multiple axes. Then I'm saying select this axis and plot this x and y. Okay, then select again this axis and set this title, set label, and then at the end show plot.show. So this is object oriented approach if you see this. Okay, because why? Here if you can see that I am clearly creating an object first, and then I'm calling something on that object. Okay, and these are the things that I'm calling these functions on that object. Object is basically AX if you see this. The second approach is can do the same thing, exact same thing, but it will be a pyplot style approach. So in that the data created is similar. So what we'll do is we'll just plot it like this. So if you see this plt.plot, now initially what I did is, if you see this object oriented style, I created two objects, figure and axis, and axis can be multiple, so it depends on what is the argument that you give in the subplots. But here if you see, I directly said plot.plot, plt.plot, created Okay, then plt dot title, set it, and x label and y label. Okay, I did not create any object. Without creating these objects, I directly made the same thing. The output is basically similar. There is no change in the output if you see. Okay, so these are the two styles. So one is OOP style and the second is PyPlot style. So in OOP style, you basically have more control over the plots, as you can access and modify individual elements. Okay, axis style. In PyPlot style, the syntax is more concise. Okay, syntax is more, you don't have to create, you don't have to write a lot of code, but they have their own advantages and they have their own problems. So if I say one advantage of OOPs is that you have control over the individual objects, and in PyPlot style, the code is pretty much concise. Okay, if I now want to, the second thing is, if I now want to create, let's suppose multiple these subplots, and I want to have subplots. So let's suppose I want to have 4 plots. Okay, 1, 2, 3 and 4 like this. I want to have 2 by 2 grid or something like that. Okay, how to do that? Okay, so now we'll use object oriented style, and sometimes I might switch back to the PyPlot style. Okay, so what I'll do is, the first thing is I'll create some data. Let's suppose this is the data I'm creating over here. So I'm saying x is equal to linspace 0 to 10, give me some random samples, and y1 is sine of x, and y2 is cos of x, and y3 is np dot exponent of x, and this is logarithm of this x plus 1. So these are my 4 functions which I just took from the numpy. Okay, and this is how I create numpy array, which is the values are between 0 to 10, and there are such 100 such values which are equidistant. Now what I can do is, if I want to create, let's suppose I want to create 4 plots, basically 4 figures I should have. So I'll say figure, comma, axis. So I'll put axis over here, and then from the previous discussion, you know that we'll say plot plt dot subplots. Okay, there are how many subplots you want. If you see the documentation of subplots, okay, if you see the documentation, today we'll see a lot of documentation also. It does not pop up here, we can check it later. And then I want 2 by 2, that is, now it showed, I want 2 rows and 2 columns. Okay, and then I'll also set figure size. So I want the figure size to be not figure, and that documentation says that it is figure size. Okay, figure size I can put it, and figure size takes a value tuple. I'll say 10,8. Okay, if I just print this one, so it should not ideally show anything, but in the Matplotlib, in this IPython notebook, it does show it like this. So here, if you see, we created these many number of plots. So if I just decrease it, let's suppose 8 by 4, something like this. I want smaller plots so it's visible on the screen. Okay, this is the size. I want to create a 2 by 2 grid of these plots. Okay, these are my subplots, and each of this is called an axis, and the whole they are called as subplots. Now what I can do is, I want to plot, I have how many functions? 4 functions: sin x, cos x, exponent, and log. So on the first plot, I want to create the sin x, then cos, and on the second, on the third, exponent, and on the fourth, logarithm function. So how to create now? How to create this? Now, as this is object oriented style, so what you have to do is, you will select this. If you see this ax, okay, if I print the length of this, print length of ax, so I consider that it should be 4. If I just show you this, the length is basically but the length is 2 because it's 2 by 2, so the total should be 4 in some. I should be able to get those 4. Yes, sec. I am getting some sound from the background. Let me just close it. Okay, so if you see it over here now, so what I am saying is that there are 4 plots, so I should be able to access them. So I am saying the length is 2 by 2. So how to access each of these is ax, as you label, we have learnt about indexing, selection, or all these. So 0, 0 is selecting basically this one. If I say ax of 0, 0, okay, and then similarly ax of 1, 1. Now I want to create plots. Okay, so I can put a comment over here, hash create plot, something like this. So I'll select this because this is a tuple of a thing, so I can select one of them. So ax of 0, 0, I have selected that, and then I'll select dot plot. Okay, and after dot plot, I can say x, because x is the same number, and comma the first y1. What's my y1? I think it's a sine, so y1 is sine. So if I plot this, then I can put a label also. So I can say label is equal to, and I can put sine of x, let's say, something like this. And after, if I print this, let's suppose I print this, I'll test it again. So if you see, now I have put a sign over here. Now similar thing, if I want to do something same on this, I also want to plot cosine, let's suppose. So what I can do is x1, y2, because now if you see, I am selecting the same object, ax 0, 0. So cosine will also, so cos of x will also get printed on the same, this plot, on the same subplot. So now if I print this, you can see this. 2 functions got printed. Now what I can do is, I can set title for it. I can set title for this. So how to set title? So just select it, and then we have a function set title, set title. Okay, now how to set title? Set title basically takes text, so we can just write it trigonometric functions. Okay, so and if I now click it, you can see the title of this plot, the title of this subplot rather, is trigonometric functions, because I'm still working with ax of 0, 0. So that's why I said it gives you access to the individual objects, and it makes it more easier for the programmer. So now I can also set x label and y label. Let's set how to set that. Ax of 0, 0, again select that object, dot, then set x label, set x label is there. Okay, then you will say that, let's suppose this is x, and then y label is f of x. Let's suppose we have a function, so this is f of x. Oops, f of x, and here we can set it like this. Okay, now you saw this is f of x, and here you will see x also somewhere. You should see it, but it's not visible. Then we can also set legends. Okay, I am just revising these things, we have seen this. So legends, okay, because now we will set legends based on the labels that we have. Okay, this is the function is legend. Now if you see, this is sine x and cosine x. Okay, now the same thing can be done for other plots. I'll just show one more plot, so that let's suppose we'll select this fourth one. So fourth one will be a of 1, 1. Okay, I'll just change it. So this will be a of 1, 1. Okay, this is 1 and this is 1. Now I want to copy this. There are shortcuts also to change all these things together. VS Code gives you those shortcuts also. Okay, let's go the hard way, don't worry. Okay, now what I want to do is I have y3 and I have y4, and I think y3, if I remember, is exponential function. I'll go back. We have that here. y3 is exponent, and then we have logarithm. All right, x of this and log of x plus 1, something like this. Okay, and now these are just functions. I'll call them functions. If you now see, these are the functions and these are the values, and this is my x and this is my y. I just selected this. Okay, then you can say this, that as they are overlapping over here, if you can see, these things are overlapping. I don't want them to overlap. So what you can do is, there is a function for this, figure.tight layout. Okay, figure.tight layout. If I just click there, and they should separate out now. Now you can clearly see that there is no overlap. So this x is also visible. Initially this x was not visible because it was overlapping. Okay, and now you can also do something on this, and similar thing can be done by using your pyplot style. I'll just again do the same thing. Now we have the data. If you just want to do it with pyplot style, do in the pyplot style. So what we can do is, so you just have to write plt.subplots. Okay, so this is plt.subplot. I said 2 by 2, and this one says select the first one. Okay, the same thing can be done. So I'll just write like this, plt.subplots, and then I'll say plt.plot, plt.this, and then if you see, let's suppose like this, and you got this. Okay, now if you want the second one, how you can do is, you can say the same thing but subplots 2, 2. Let's suppose I'll just copy this code and I'll paste it over here. Again the same thing, but the subplot I'll keep 2. Now I'll say 2 because I have created a grid of 2 by 2 plots. Now I am saying select the 2 and select the y3 over here. Okay, and maybe y4 over here, and let's suppose some function f and some function g, and just functions. Now if you see this, you can see we got this, and again you can say this layout should be tight. You can say plt.tight, so that they don't overlap. plt.tight layout. Pretty much basic stuff. You can see it clearly now. Same thing can be done. You can create multiple figures, but one change that we have is plt.subplot, and we give the size, and then we also give the number that we are assigning, because it's 1, 2, 3 and 4, something like this. Okay, and here you can see that in object-oriented approach it becomes more feasible because you can select one object at a time, and similar thing can be done here also. Okay, I hope this is clear. Is it clear? Any questions on this? Any questions? Now that we saw a lot of functionalities, and at least we saw 2 approaches how to basically plot these things onto your canvas. So now there are different things which you can manipulate. Okay, let's make a basic plot first, and then we'll keep on adding things onto it. Okay, this basic plot, you should be by now experts. So this is import Matplotlib as my pyplot, and then this is x, this is my y-axis. Plot this and give it a title, give it x-axis, give it y-axis, and show the plot. Okay. So this is how to do it. And then now what we can do is, we can, if you see this, this is basic. If you want to, let's suppose add legends now, so you can add legends also. So legends, for legends, let's add labels first. So I'll change this. So this was the basic plot. Now if I just add legends, you know that how to add that plot, and I add label 1, label 2, and then I said plot with a title and a legend, and this is my x-axis, this is my y-axis, and legends, and dot show. If you see this, this should look a bit better. My y1 and y2 is not defined. Let's define this as y1. Let's define this as y2. Maybe we'll change certain numbers, 10.5, 15. This is 19. Okay, now if you see this, these are the two line graphs that we have. Okay, here we have added these legends. And what's the function? Dot legend, x label, y label is the labels, and title is the title of the plot. Okay, now you can pass it. If you see, these are the two lines. So what I can do is, now you can add the markers also. Okay, let me actually create some data. So I want to create some actual looking straight lines. If you see this, these are two straight lines now. Okay, now what I can do is, if you see this plt.plot, I'll go to the documentation and show you there are different things that you can do with it. You can do a lot of things. You can add color, you can add line style, you can add markers, you can add labels. So we'll see all of these. Okay, now I'll go to the documentation. So if I open the Chrome, you will be able to see the documentation. Now let's suppose here, if I search for pyplot. Okay, now you can see this matplotlib.pyplot is here. Now the function says that, oops, is it the pyplot, matplotlib pyplot.plot? I'll have to, this is the function, because we are in dot plot. Okay, yes. So if you see the signature, you see the matplotlib.pyplot.plot. It takes the star args, the scalex, the scaly, and data, and these keyworded arguments. Now the first thing is, it shows the signature over here. The document shows signature. So it shows plot x and give y, and this is some formatting. Then this is some asterisk, and then we have data is equal to none. This is the signature it takes. Okay, if we go a little bit low, we have seen this. We have seen this plot x, y, and this is my formatting. Okay, this is showing just one example. If I just see this example, it will show you something. And you can see line width is 2. I want to actually go over here. So these are the parameters. It's explaining the parameters now. Okay, so it's saying x comma y, array like scalar. So it is taking either array like things or the scalars. Okay, and it has mentioned it here. The horizontal / vertical coordinates of data points. You give the coordinates x value are optional, because if you don't give x values, they're optional, and if you only give y values, okay, it will by default take this y values. Okay, we have not seen that even. So let me also show you that. Going back, I'll show you the code window. If we just give one values to it, so I'm saying if you don't give two values, because since now we have been giving it x and y, so if you just give it one value, so if I say plt.plot, okay, and then if you give just an array like 1, 2, 3, 4. So what documentation is saying is that this will be considered as y value. Okay, these will be y value. So x values will be just inferred from it. So if you see this, so this is just a line. Okay, if I say 1 square is 1, 2 square is 4, and 3 square is 9, I just want to make function x square. Now you can see this, it made something like this. Okay, that's what documentation says. Okay, you can just give the x value, you can give the y values, x values are optional, and I showed you that thing also. Going back. Now if you see this, then we have this fmt. Fmt is basically a string. So what it says is, it says a format string. For example, RO means for red circles, see the nodes for this RO, and it might have nodes. So let's check this RO. So RO, what will do, it will give color red, and these points will be now circled. Okay, now let's do that. Okay, so if I go over here, so now what I'll do is, I gave this, and I'll say comma. Now I'll put this format string. Okay, format string was RO. If I do this, you can see that I got these points. Now I have 4 points, I got these points. That's what I'm just following documentation. I'm showing you how to follow documentation. Okay, just, can you see it now? So what I did is, I said plt.plot 14916, and then we have this RO, RO basically is a marker. It's a format string, what they call as FMT in the documentation. So then when I just added this, so it gave these red and circles. Okay, going back to the documentation, I should rather show it like so that Chrome is okay. Now you can see this documentation again. Okay, now this is the format string which we saw. Oops, I went ahead. This is format, and then we have this data should be there if it is indexable, and it returns a line, basically list of line 2D, a list of lines represent the plotted data. Okay, then there are these other parameters which they have mentioned, and the most important thing is this keyword arguments. Okay, so in keyword arguments, these are all things that you can do. See how many properties they have kept. They have kept, you can say color for C or C. Okay, let's check this color and this is C. Okay, let me just open VS Code again. If I just plot this color now, so this was the FMT. So if I now say color, this is now a keyword argument, and we have well studied it in Python how to get keyword arguments. So now color can be, let's suppose, a red. It was already red, and now you can see line is red. I can also put, let's suppose, green. And you can give colors in hexadecimal also. By hexadecimal, I mean each color has some hex value. If you just copy that and paste it over, that will also work. So this is one argument. This color is one more argument. And now if you see again the documentation, and there is some more things like dashes, there is something gap fill, in layout, label, line style, line width, marker. Okay, if you just copy this line style, I just wanted to show what it'll do. It will basically give you a different styles of line. Now if I just paste this over here and I say line style is equal dashed line. Okay, dashed means like this. And now if I print it, you can see this is a dashed line. Okay, and all these things are mentioned. So why I have remembered some sort of these things, but I have not remembered all the things, but they are mentioned in documentation. Again, going back to the document, you can see that. Now where can I see this line style? So if I just click it over here, you can see it will mention all the line styles. Okay, solid lines, dashed line, this, and dotted line. None means drawing nothing. So it will have all these. So these are the parameters you can take, and you can take offset also. Okay, how much far they should be. It can take that value also if I am correct. Okay, and set line width is also there. So I'll go back where we were. So we saw a lot of these things. Okay, visible also you saw in the previous. Visible takes a bool if you just want to make it vanish something. So dashes, colors. So we at least saw color, line style, and line width is one more thing. Line width you can have over here. This is the line width. Our shortcut is LW. So I'll say line width. So comma line width. I should exactly spell it the similar fashion. Line width. This is equal to, let's suppose I'll give some value. This takes a float value. If I give 1.2, something like this. Okay, now if I see it, you can see this become a little thinner. Let me just put it 12. You can see the line became much thicker. Okay, this is line width. Okay, and these are also used as methods. Okay, if I just remove this. Okay, I believe that these are also, let's suppose now we have this. So what I can do is I can set dot, and then I can use this method. Set width of this, and this W is the float parameter. So dot, oops, this is line width, and I'll just copy this dot, and W is a float value. I'll say 12. That is something list. It is a list basically. I'll have to convert it, but I'll have to also check the document. Does it support this way? Because I was assuming this is a method. Maybe it does not look like a method. No problem. That's the way how you should read documentation. So you read document, you experiment something, it does not look like that, and then you again back and read it. Oh, it is not working like this. Okay, so going back over here, you're not able to see the code though. I'll show you this. So I was showing you this. This is line width. I think you did have not seen line width. So line width is equal to 12. You can see this, you got a much thicker line. Okay, and if I again go back to the documentation, you can see a lot of other methods are there. Okay, and you can make use of them. there are dashes. Alpha is basically a scalar or none. Alpha value should be for the transparency, I suppose so. So set alpha value for blending, not supported on all backends. Okay, set alpha must be within 1 means full opaque, 0 means fully transparent. So if I just set this alpha also now, okay, I hope you are seeing that. Oh my god, I have just kept the code window over here. If you see, this is the documentation of alpha. So alpha is over here. I just checked the alpha. So alpha, I was assuming that this should be for transparency, and it was for transparency. Set the alpha value used for blending, not supported by all backends. Alpha must be within a range of 0. As I said, 0 is for full transparent, 1 is for full opaque. Opaque means it will appear. So if I just show you it in the code, I'll just put again the code, and I'll say alpha is equal to some value. I'll say comma over here, alpha is equal to, let's suppose 1. 1 means full opaque. That means nothing should get changed, because that's the default value also. So 1, if you see, nothing got changed. But if I just decrease it a bit, if I say 0.5, you should see that this line should get a little bit lighter. Here you can see this line got a little lighter. If I say 0, that means complete invisible. It should disappear. You can see that it disappeared totally. It is there, but as alpha is 0, it is not showing up, because we have kept transparency value 0. It should be fully transparent. 1 means full opaque, 0 means full transparent. And let's keep some value so that this is there. Going back to the documentation, you just saw that I just clicked on plot, and you saw how many things there are there, and we are in the star keyword arguments. Okay, they are the keyword arguments. Okay, and these are all things that are taken by keyword arguments. Okay, and then you can have this fmt. Now usually what people do is they have to format string. Okay, and they have to set color, and they have to set a marker and line and the color. So what sort of line should be dashed line, and what point should be. So in short, they'll keep it as a string, as we did it. Okay, we did it as ro. Let's suppose I'll go back to the code. I'll show you this. Let me create a new plot now. Okay, let me create some plot, because we have x and y values defined. I'll create 2 plots. So if you see this, now you can see these 2 things. So I have added color, line style, and the marker, and then label also. Okay, so this is my x data and y data, because I have 2 lines here now. One is red and one is dashed, and this is solid, and this is a marker. So how I can do it in the shortcut? Okay, then there are these for fmts. So what I can do is I can just replace this color, line style, marker, okay, with a string. Okay, how to add that? So r, and then circles maybe, and dash. You can see the same thing is there. Okay, nothing changed. I just replaced 3 arguments with this. This is less readable. I would prefer this one. Okay, I would prefer this one. Color is let's suppose blue, and line style, and I have just usually here you take this first, you take the marker first, after this line style. So again the same thing can be done. Okay, if I just do it for here, so it is color is blue, and then we had I think dash lines, 1 dash line, and then we had x marker. Okay, now you can see this. Okay, so this is the shortcut. So this is what documentation calls it, fmt. If I again show you the documentation, it calls it fmt here, and it says you can start with a marker, and then say what type of line it is and the color. And now how to say which is this, and it says this. These are the markers. This is point marker, this is pixel marker, this is circle marker, this is triangular marker, triangle up marker, triangle down. Okay, I hope you are able to see all these things. So these are all the markers, and these are all the line styles, if you can see, and these are all the characters that can be used for color. B for blue, G for green, R for red, C for cyan, magenta, yellow, black, white. All of these are these things. Okay, this is how I usually read the documentation for each of these things. Okay, we started with here, and we saw all the things that it provided. So Matplotlib has this plot, and then I showed you there are these star args basically, which takes this x and y value, and then fmt. This was just a call signature. When you call it, the signature is basically how do you call it. And then most important thing starts from these parameters. X and y should be like this, fmt is this, and data it should be indexable. It's also optional. Then in the other parameters, that keyword arguments, it even writes it here. So keyword argument, line 2D properties, they're optional also. They're not compulsory. But if you want to have those, all of these properties are there. Aggregate property, alpha, animated, these initialized, clip box, clip on, clip path, all of these things are with the plot. Then even with this, we have this format string, and it explains the format string again. and then it shows you different characters to use for different colors. See how clear the documentation is? Is it clear, or do I find it clear? What is your opinion on this? Is it actually clear? Am I the only one who finds it very clear? And you should have a habit of reading documentation. Okay, this is one of the art, but maybe in the first initial iteration you will find it quite hard because you will want to find answers on the fly. But it's better to go to the documentation. Once you go to documentation and maybe reiterate a couple of times. But let's suppose here, if you see me doing this, I have been doing it since quite long now, and it for me, I know a structure. What structure usually they follow? Okay, these are the parameters. So for you people, probably it will just take you a couple of weeks to get accustomed of reading documentation. The more you read it, the better you will become at reading the documentation. And documentation is the only go-to weapon. You can search anywhere. If it supports, it will be there in the documentation. Okay, whatever other tutorials, whatever other books say, all are mostly taken from the documentation. Okay, and that's why you should rely on the official documentation more. Sometimes, most of the time, because now that internet is becoming so humongous and we have so many libraries, so many functionalities, and it's impossible to remember everything for an individual. So it is better to keep on going back to the documentation. I highly suggest you people, whenever you're doing something, have the documentation page open with you. Okay, and even don't search either on Stack Overflow. The initial goal should be like this: when you are learning something, keep on going to document, keep on doing that. Even right now, when I have some time, I still go to python.org. Okay, and I go on that website and I see, is there something new, and I always end up learning something in there. And maybe that time I will not use it immediately, but sometime when that's in the back of my head, and after some problem comes up and I suddenly remember that, oh, I read that from the documentation. So documentation is the best tool. Okay, if you even are maybe beginners in some tool, have a habit of going to the documentation continuously. I just showed you one example. I just showed you the example of plt.plot, and that's how many things we just learned. Okay, by just seeing the one page of the documentation, and for all the functionalities that are there, they have given the documentation for everything. Okay, because when they were creating, parallelly people write documentation also. So if you see, all these are the functions that you can use. Okay, and we are in pyplot. Okay, and these are the functions that are there in the pyplot, and we are in pyplot.plt. Okay, .plot, and in that I showed you one of the functionalities. And you have pyplot.scatter, histogram. You have a lot of things, arrow, QR, and you also see this title. Okay, and this title is also worth seeing. If you see this title, and you can directly go to the parameters now. Parameter, it takes a label, and font, it also takes. The use of font dict is discouraged. Parameters should be passed as individual keywords. Okay, it also takes this font dict. Okay, that means font, what should be the font size, font weight, color, vertical alignment, horizontal, but it is saying that it is discouraged, don't use it. Okay, and location is where should be the location. Okay, let's suppose we will test it with the title also. I'll test it in front of you. Let me see the code. If I want to, let's suppose, set a title, what I can do is plt.title. Okay, now according to the documentation, it takes a label first. Okay, let's give a label, our title. If I just print it, you can see our title is there. Now I know there are a lot of other functionalities. So what I saw is it can also take a dictionary. Okay, I'll just take that dictionary. I'll copy the dictionary from the documentation. Okay, I'll say this is my some dictionary, which I'll say like this, and then I have to call this RC parameters. I have to import some things. Okay, let's not, because I don't want to debug it. Debugging takes a lot more time. Let's be safe. Okay, so what I can do is I can say location. There is an argument, it takes location. Now it's a center by default. If I take it left, I can say location is equal to left. That's all the things that I'm seeing in the documentation. I can parallelly show you that I'm just copying it from the documentation. Okay, this, if you can see, I just copied this left. Okay, and this y is the float value default. It is saying default none, vertical axis location, where should it be located? 1.0 is at the top. If none is the default, and you can read it from here. Then pad, how much should you pad? Okay, and it returns the text. If I just go, let's suppose, again to the code, and if I run this line, many other things I don't use usually, because usually the title is on the top and I don't tinker it. If you see this, our title now got shifted to the right, shift to the left. And you can also maybe have a customized font also. If you want the title should be, let's suppose, something where you want a custom font, you can also do that. Okay, so these functionalities are there. So I think that they're in the dictionary. If I again go back, so here you can see a dictionary which takes font size, font weight, color, vertical alignment, and everything. And you should go through them and experiment, because I don't want to do it here, because maybe we'll get bugs and we'll have to. And then we are also taking keyword arguments. Okay, and they are text properties. Now let's click on text properties. If I click over here, so this is the text properties again. A lot of things are there. Again, the same thing. Font style. Let's use this font style. If I go back to the code, so I should be able to give a font style. Let's suppose this is italic. Okay, if I run this, you can see that it got italic. If I say bold, it should be bold. No, bold is not that. Let me again see what is the document. You can see clearly that I myself don't remember these things. Let's go to the, if it is there. So font style, it is oblique, not bold. It's normal, italic, and oblique. Okay, let's copy this oblique and we'll see what is the effect it has. Go back to the code, and it was here. It was even showing me that it's oblique. I'll just paste it over here. You can see that this should get oblique. So you saw this, our title got oblique. Okay, and what else is there? So let's go back to the documentation and see what else is there. Okay, so if you see it over here, font weight is there, font style, font stretch, font family is also there. Okay, font family is what sort of font do you want. Sometimes you also maybe want to tinker with it. So font family, if I put it, I'm just doing it for your sake, so how to follow documentation. Font family is equal, and I don't know what fonts there are. I'll need to check. So it shows this is fantasy. Fantasy is a font. Otherwise, you can install these things also. Font fantasy not found. It's not found in my this. So found was Chicago this. So I'll use Western. I'll use whatever is available in my system. It even did not show this. Okay, you'll have to probably install these font families. Okay, you have to install all of these font families in order to use this font. One more thing that you can do with this title is, which many times you'll probably do, which sometimes I have done, is increase the font size. Okay, and that is a good thing. So that will also be in the documentation. So if I just show you that, so font family, font size is there. Okay, font size and font stretch. I don't usually font size. This is a good parameter, because sometimes you want the title to look a bit better. Okay, and then it takes values, args, and it also has its own signature. You can see that it takes values. Font size, float are this. You take a float value. Let's suppose I'll give 12.0. It will be way bigger. Maybe I'll give 100. 100 should be way bigger. So you can see this, our title got a much more bigger. So I'll probably give 25. Sometimes you might like title like this. And now I don't want it on left. I want it to be at the center. Center, I wrote the wrong spelling. This is center. So I'll just paste it over here. And you can see now, this is our title, a little bit bigger. And I just showed you for the title also how to follow documentation. I showed you for the plot and for the title. And similar thing can be done for this X label, for this Y label, for the legends, for all the things that we have seen, these small functions. And there are these, oops, I was not showing you the code. This is the code which I want to show you. Let's suppose if this is the font size can be given, let's suppose 25, I will give 100. If you see 100, you can see that it will become a lot bigger. You give 25, a little smaller, and I also kept it at the center. It was at the left. Initially it was like this. I now kept it at center. Okay, the takeaway point here is that you should rely on the documentation. You can see that we saw plt.title, we saw plt.plot, we also saw, let's suppose, other functions that we haven't seen documentation of, but you can just go on the documentation and check it for yourself. What other things can I do? Okay, I can do something with the label, I can do something with the title, I can do something with these stickers, I can do something with these spines. So all of these functions which are there, you just go on the documentation and tinker with it, and you will figure out what things are doing what. Okay, and I just showed you few functionalities in the documentation, and there are a lot of things that this PLT provides. Okay, if you see the documentation there, you can see humongous number of methods. I'll just show you at a glance. So if you just see these things, going back and go back once more. Okay, this is plt.plot. If you see this, in PyPlot you have a lot of these things, and each thing has a documentation. You see how many methods. Isn't it humanly for me impossible to teach you about every method? You see how many methods just in PLT, just in plt.plot you have these many things. So I have just shown you some of the important things which you will use almost. I have shown you this title, I have shown you probably this y limit also. If you want to limit y-axis, you can also limit x-axis. Okay, how many numbers you want to show on there. We also seen tick params. What we have also seen, we have not seen this legends. We have seen annotation also, how to annotate, and all of these things can be read. You can read about all of these things. Okay, there are a lot of these things, and be in touch with documentation, and you will get to learn about these things. One thing I wanted to show you is basically there is a function fill between. Okay, fill between itself is not in that's in PLT. It is not in PyPlot. So if I can show you this is my PyPlot as. Okay, this is basically, I'll just run it. It's not in the plot function. If I can see, fill between is a function. If you see this, it is in the axis, fill between. Okay, so let me just create something and I'll show it to you. Fill between, if you have two curves. Okay, let's suppose sometimes you have a sine curve and then a cos curve. Sometimes it becomes really easy to visualize if you can fill the gap in between. So I'll show you in the code. So let's go here. This is visible. So you can see that I just created x and then y is sine and cos, and I just did this. I said plt dot fill between. Okay, fill between basically means whatever is the between space between these two curves, fill it. You can see this, it filled the curves. Okay, and again you can read the documentation of fill curves. So if you want to do that, fill between, and you can just hover over the documentation, search for fill between, and then you can see there are a lot of these things. These are parameters, what it takes. So even in should we interpolate, and what is the step, and then there are keyword arguments. All of these are pretty much similar. And there is again, this is fill between two x, this is y values, and if you want to fill between x, okay, what you can do is you can also fill between x. Let's fill between x. Also want to see what will happen. Now it will fill between x axis. So this is the function. Okay, now you saw that did something here which doesn't make sense. Okay, but sometimes in some cases it might make sense. Okay, so fill between looks much nicer with the x. Okay, this is with the y curve, and if you just I flipped it along the y-axis. Okay, then one more important thing is how to save it to the file. Okay, you can save these things to the file also. So if I am in the ls, so I can just, ls is a command which will list all directories, so I can see nothing saved here. So I'll save these things. So what I can do is, let's suppose I'll create this. I have this plot now. I have this plot with me. This is the plot. If I want to save it, what I can do is I can just say plt.save figure. Really easy. So if I just put it here, plt.save figure. If I show you it over here, now it got saved. So if I again do this ls, it should be somewhere there. Okay, you got this plot.png. Okay, this is the plot. This is the function. Can you see it? So it got saved. So now I can even maybe I should just enable sometimes completion. Let's suppose why copilot is necessary now. Let's suppose I have to read this. So I can say hash import image or display image. I can just write this comment, display image. So you can see copilot will do something. Okay, now see, and I want to print this image. Image.show. Okay, this is the image. Most of you will be coding with Copilot like this. You can see this image over here. It got saved, and I showed it with this. This PIL is again a module, and I import image from there. Image.open.this plot.png. Okay, if I have to remove it, let me remove it. Remove this file which is named as plot dot png. Okay, it got removed hopefully. So if I see ls, there is no png, there is no file like this. If I replace this line of code, if I now show, it should show file is not there. Okay, no directory found. If I again save this file over here, if I save this, now it should pop up over here also, and now over here also. Okay, this is the file that we have saved, and you can see how beautiful this image is. You can directly put it in the research into a presentation howsoever you want it. Okay, and I'll just disable the completions. Okay, usually I whenever I code, I use this Copilot with me because it makes it really easy, because I don't have to search for much syntax. Okay, because it just gives the suggestions. This was how to save the things to the file. Are there some other things to show? There are a lot of things. You can do a lot of things, a lot of customizations. Okay, and it looks very pretty also if you do these customizations. But that is up to you. However you want it, that is up to you. Howsoever you want it to be done, you should do that. Okay, one more thing I want to show is array of multiple axes you can also have. Let's suppose you have data like this. This is your x-axis, and now you have array of arrays. This is 1 2 3 4 5 6. So each of the column will be taken as sort of one function. It will be taken as y value. If you just print it like this, so you will see that x value is 1 2 3. Okay, then you have two columns over here. Two different plots will be plotted. Okay, you can see this, because plot of each column of y against y, and if you just use this syntax, okay, each column is basically treated against this x. Okay, and this is equivalent to if I write a for loop. Okay, let me write a for loop like that. Let's suppose I'll write for columns in a range of, because now I have this y value, y dot shape of 1. Oops. Okay, and then I want to print this plt dot plot. Oops, what am I doing? So I should write this plt dot plot, and then I can print it like this is my x, and this should be, oops, I'm somewhere else. This is x, comma, select that y, and select everything from that, and only select that column, that particular column. This is why going through the shape 0 and 1, and then what I'm doing is select every row and only select that column. This is doing it iteratively. plt dot show. So there is some error. What is the error? Let's see this. X and y must be same in the first dimension. Is there something wrong? Can somebody see it? X comma y, I see it. Check it. Okay, yes. So here I probably missed the comma. Yes, I missed the comma. This comma I missed. You can see a slight mistake. It led into an error, and this error was giving me no clue where I missed. Okay, I missed actually this comma because I had to. So this line is telling me for columns take all the take the index the columns, because this shape will give me a tuple. The shape of this is the shape of this. If you see this array is a 2 by 2 array. So I have the shape as this, like we have 3 columns. Rather, this is 3 by 2 shape, but I want only the second element. So I'll take 2. This y dot shape will be 2. So I'll say 0 and 1 and 2. So because this 0 and 1, rather the shape is 2. I should rather print the shape. Why to just see it? So I'll say print y dot shape. Y dot shape will be a tuple. So it will be number of rows into number of columns. So I think 3 by 2 it is. Y dot shape. Okay, the shape is like this. If you see it over here, 3 by 2. So I want to iterate over columns. That's why I said y dot shape of 1. Of 1 basically means take this 2. Okay, now it will iterate from 0, 1. Okay, and then it will give me this. It will give me the shape of this. So after we have the shape, I am saying plot x and, but in the y, select all the rows and that particular column. Okay, select all the rows and that particular column. So it is doing initially selecting the 0th column. Okay, and plotting it x against 0th column. Then it is showing x against the first column. That's what we have over here. Okay, that's it. This is equivalent. So these two things are equivalent. This and this. Both of these showed me the same code. I wanted to show you one more of this. So because you can use this as this. Let's suppose sometimes you have array of arrays and you want to use columns of one array. for against the x-axis, so you can use directly without writing the for loop. Is it clear? So colors, markers, we have seen all of this. I am just parallelly running through the documentation because these look so beautiful. I wanted to make animations and things. So if you see this is one more line. So here you can see this is the format string. So format string is this is triangular, this is k means black, and this is dotted arrows. Okay, and this is 1 2 3, this is 4 5 6, this is the plot that it's showing over here. And I think we have seen additional keywords also. There we have seen label, line width, label, and everything that we have seen. Okay, so is there something else? No. Yes, one more thing I'll show you over here is a beautiful this. Any questions till here? I don't think you should have questions till here because this was too basic stuff and we covered it in pretty detail. Now we have seen a lot of graphs, so we'll see one last graph for today's session, and then from tomorrow we'll basically see what is called as typographical graph, different types of graphs. So what I'll do is I'll probably just make one graph and explain you line by line. I have commented it out also. So if you see this, okay, the first thing is we have created this. So this is the range of x-axis range values range from 0 to 5, and we have 20 such values. So we are adding title to this, x label and y label, and now we have a text. So we are putting this first, second, third, and fourth, and this is the text. There are annotations. If you see on the graph, I have kept the annotations. Okay, this is first and second. I am naming the points. Usually you might have seen the coordinate. You usually give these ordered pair of points. So here I have just named them first point, second point, third. This is how the text should be. So first, second, third, and fourth, and these are the coordinates that I have given. This is for the text annotation. Okay, then if you see plt.text, I am adding special text annotation, this y is equal x square, this thing. So if you see it over here, I have written in LaTeX. This is the syntax we write in LaTeX. If you have some experience with overleaf or TextEdu where you write research papers, usually the mathematical equation are written in LaTeX. So what I am doing is plt.text, add this text at this position. So this is the text. Okay, font size is this, and then bbox, it takes this, the face color is yellow and alpha is 0.2. Okay, this is the text that I got over here, y is equal x square. Then I am plotting these three things. Okay, these are the plots, and then I am adding these legends, first series, second series, third series, and I am also adding location. Where should I add it? And this is location 2. Okay, then I am adding this plt.show. This is how the graph looks. Okay, I showed you different controls. So here you can see squared values, you can see counting, and then we put this value annotations for the first, second, third, and fourth, and then we also wrote something in LaTeX. If you just want to say something else, you can just change in here. Okay, if you see these dollars, this is how we write in LaTeX the equations of mathematics. Okay, this is the last graph where I'll end it, and in the next session we'll take it from here. Then we'll see different types of graphs like line graph, which we have been seeing. We'll see scatter plots, we'll see histograms, we'll probably see heat maps, color maps, we'll see all of these, we'll see contours. A lot is coming, and probably I'll require one or maybe more than 2 sessions at max to just wrap up the Matplotlib, the necessary functionalities. As always, I told you that it's humanly for me impossible to teach you every functionality of Matplotlib, because these things have been developing I think since a decade or more than a decade. So they have quite a lot of functionalities. So I'll just give you the capacity, the capability that you can go through documentation and just read the things there and come up with the plots. But I should give you the basic knowledge, but at least you have the head start where you can now start from, and it will become easy for you. So with this, I'll end today's recording. See you in the next